Okay, today is day 3 of Unit 7. We started today with a ticket in the door. So if you missed class, you'll need to make that up. And then after the ticket, we just started with the lesson. So we'll go ahead and start here. So copy those in your notes. So 7 to the 1/2, we want to rewrite that in radical form. So I taught this earlier in the year, and this is also from Algebra 1. Hopefully you remember that a fractional exponent can be rewritten as a radical or a square root or a root. So I first make the root. Because of the denominator being a 2, it's a square root. I can either put the 2 there as the index or not because it's a square root, and then 7 to the first power. That's how we rewrite that. So that's the same thing as me just saying the square root of 7. So 7 to the 5/2, same idea. 7 is to the 5th, and that's the square root. Again, I could put the 2 or leave it blank, but that's how we simplify 7 to the 5/2. Another thing you can do is make it the square root of 7 and then put the 5 exponent on the outside of the square root. They are equivalent, so either is fine there for radical form. So then we can go the opposite way. We can start with it in radical form and put it in exponential form. So I copy the base, and then the denominator is the root, or the root is the denominator, and the exponent is the numerator. So that would be 2 to the 4/3 power. Okay, so we're going to try these. So this says simplified. We are going to put 125 to the 2/3 in the other form, in the radical form. And that'll help us to simplify, meaning tell me what it equals. So that's the first thing I'm going to do is rewrite it as a root. Now, I could either write the cube root of 125 and then squared underneath here with the 125, but I don't know off the top of my head what 125 squared is. On the other hand, I do know what the cube root of 125 is, and then I can square that. So that step is simplifying it in that manner rather than this, or they're equivalent. They're both fine, but this I'm not going to be able to simplify without a calculator, whereas this one I am. So we're going to go with this step instead. So the cube root of 125 we know is 5, and then 5 squared we know is 25. So 25 is the final answer. So let's try this one. Same idea. 16, the 4th root, it's cubed. I could write it like that, but again, what's going to be more useful to me is to put the 3 on the outside. So if I take the 4th root of 16, well, we know that 2 to the 4th equals 16, which means the 4th root of 16 is 2. And I cube it. 2 cubed we know is 8. The final answer is 8. So now we're going to try some with negative n fractional exponents. So that we still apply the rule with negative exponents, which says the reciprocal of the base. So I am going to put 1 over 8 to the positive 2/3. And then I'm just going to simplify 8 to the 2/3 the way we just did in the last couple problems. So that's the cubed root of 8. And that's squared. And that's still just under 1 at this point. The cubed root of 8 I know is 2. And 2 squared I know is 4. So 1/4 is my final answer. So you might want to, I don't know, pause the video and try this next one on your own first to see if you understand how to do it, and then play to check your answer. So same idea, 1 over 100 to the 5/2, which is 1 over the square root of 100, and that's to the 5th power. And the square root of 100 is 10. And 10 to the 5th, hopefully you know the trick with exponents of 10. I just put a 1 and then 5 zeros because the exponent is a 5. So 1/100,000th is the answer for this one. Okay, so now we have to involve some variables as well. The first step is going to be the same. I am going to put this in radical form. So 64x cubed is the cube root of that, and I'm going to square it. So after I've done that, I'm going to just focus on one thing at a time, the numbers first, then the variables. So the cube root of 64 we know is 4, and the cube root of x cubed we know is x, and that's in parentheses because it's squared. So then I square that. 4 squared is 16, and x squared, so 16x squared. Now, a couple things you need to do before we say we're done with the problem. So first of all, this was an odd root. So odd roots, if you recall earlier in the year, I taught about when you need absolute value in your answer and when you don't. Odd roots you never need absolute value for. So we don't need to worry about that in this problem. We'll talk about that more in a later problem. But because it's odd, I won't need any absolute value. The second thing you want to check for is, do you need any domain restrictions? And we have x not in the denominator, and it's not to a negative exponent, so it never would be in the denominator. So I don't need a domain restriction on this one. 16x squared is my answer. Now, I just want to also point out that while we have to do the radical form for the number itself, so I have to do the 64, the cube root of that, and square it to get that piece, to know that it's 4 squared, which is 16. I don't necessarily have to do the variable part that way. What you can do if you want to, because we have something to a power, we know the other rule that says that we can multiply those powers. And when I multiply 3 times 2/3, I get 2. So I could figure out that it's x squared using that approach rather than putting the x cubed root of that and then squaring it. So to get the exponent for the variable, you can use either approach. You can either multiply the exponents, or you can put it underneath the radical with the number as well. So that takes care of that one. So let's try this one. 64x to the 6th, the 3/2 power. So once again, I'm going to put the 64x to the 6th. It's the square root, and I'm cubing that. So I'm going to take that one step at a time here. I want the square root of 64, which is 8. I want the square root of x to the 6, so we subtract, or I'm sorry, we divide. The 6 divided by 2 gives us x cubed. The square root of x to the 6 is x cubed. And that's still in parentheses, and that's cubed. So next, I'm going to cube 8, which hopefully you have those memorized at this point, is 512. And x cubed is x to the 9th. Okay, but we need to check a couple things here. So if you recall, in the last problem, I talked about the fact that when it's an even root, you sometimes have to worry about absolute value. And let me refresh your memory on when. So if it's an even root, which this one is, that comes out being an odd exponent, a whole number exponent. If this was a fraction, I wouldn't worry about it. But a whole number odd exponent that came from an even root, you need absolute value around. Had this been an odd root, like the last problem, we would not include absolute value. Had this been an even root that came out with an even exponent, like 8, I would not be putting absolute value. Had this been an even root that came out with a fractional exponent, I would not be putting absolute value. But because it's an even root that came out odd, and it's a whole number, odd number, I need the absolute value around it. I don't put it around the number, just the variable part. So that's my answer. Now I just have to check if I need restrictions here. Nope, don't see any negative exponents for x. Don't see x in the denominator. That's my final answer. Next one. Oh, and again, just want to go back to the other one a minute. I could have done 6 times 3/2 and gotten 9 that way. Okay, but even if I had just multiplied the exponents, I still need to think about, okay, an even denominator for the fractional exponent means an even root that came out odd. So I still would need to remember the absolute value, even if I used the multiplying approach for the exponents rather than the radical approach. So next one, once again, we can either use the radical approach or we can use the multiplying exponents approach. And some problems one might be easier, and some problems another approach might be easier. Personally, this one I think is easier if you multiply. So 12 times -1/4 gives us -3. So I'm getting b to the -3. Except that I can't leave negative exponents. So I know I make that 1 over b cubed. Now, you still have to check, though, if we need domain restrictions and if we need to include an absolute value. So the denominator's a 4, that's even. That means an even root. The 4th root is even. So if my answer has an odd exponent, that's a whole number like 3 is, then I need to include absolute value. Okay, so we do need absolute value there because it was an even root that came out with an odd whole number exponent. So we have that. Now I see b in the denominator of a fraction, which means I need the domain restriction. B is not equal to 0. And that's my final answer. Okay, one more example today. Actually, I think we have two more examples. So this one, we're going to simplify the way we've been doing the last several days. 2/4 I know is 1/2. The x to the negative 2 I know by now to move up to the numerator and make it x to the positive 2. And now I know to simplify the y's, I'm going to subtract the exponents. So I'm doing y to the 2 minus 2/3 power. I'm just going to do that off to the side here. So 2 in thirds is 6/3, and I'm subtracting 2/3, so that gives me 4/3. And 4/3 is a positive exponent, so I know that y to the 4/3 belongs in the numerator. Now, there's no need to put that into radical form because the 4/3 is just a fraction. So we'll just leave it as y to the 4/3 at this point. So I don't need to do anything else with that. And that's a 3, so that's an odd root. It's a fraction, so I don't have to worry about absolute value there. So I have my answer. I just need to worry about restrictions now. And I can see that both x and y cannot equal 0. Okay, last problem. So we're going to combine the x's and the y's because I see like terms. So we're doing x to the 1/2 times x to the 2/3. So the rule says when you have like bases, you add the exponents. So I'm adding 1/2 and 2/3. So 1/2 in 6th is 3/6. And I'm adding on 2/3 in 6, which is 4/3, or 4/6. So 4/6 plus 3/6 is 7/6. Okay, I'm going to do the same thing with the y's. So y to the negative 1/3 times y to the 3rd. I'm going to get the y's combined by adding the exponents. So negative 1/3, and I'm adding on 9/3, and that's 8/3. And so I have x to the 7/6 and y to the 8/3. Now, the 7/6, it is an even denominator, which means that's an even root. However, I don't have a whole number here. That's a fraction. So I don't have to bother with absolute value there. And the y is to the 8/3, which is a cubed root. So that's odd. So no absolute value with that. And I just need to figure out if I need any domain restrictions. At one point in the problem, we had y to a negative exponent, which means y would have been in the denominator, which means y cannot equal 0. X, I don't need to restrict that. It was never a variable in the denominator. And that's my answer. Homework, you're going to do pages 8 and 9 and page 10, the specific problems that I have listed here. That's also posted on Schoology and your calendar. So do those for tomorrow. Reminder, later this week you have a timed exponents quiz. So complete that or be ready to take that on Thursday.